practical is the determination of the amount of iron in some iron tablets, and the iron tablets I'm using are Ferrograd tablets. The glassware apparatus required for this practical are a volumetric flask, 250 ml, 100 ml graduated cylinder, some 250 ml beakers, a setup for a burette and clamp, retort stand, and a pipette for measuring out our iron solution, and a white tile for determining the colour. We also need a pestle and mortar for grinding up the iron tablets, and a balance for weighing out the iron tablets before the start of the practical. The two chemicals required for this practical are a potassium permanganate solution, which I've already prepared, a 0.015 molar solution, and a sulfuric acid solution, and I'll be using a 1 molar sulfuric acid solution. With this practical, we need 5 iron tablets. So we're going to weigh the 5 iron tablets, put my clock glass onto the balance, hit the tare button to bring it to 0, and then pop out my 5 tablets. And weigh my tablets. So I have my 5 tablets weighed out, and now I want to dissolve up those 5 tablets in a sulfuric acid water solution. But in order to do that, I need to grind down, using the pestle and mortar, I need to grind the iron tablets. So into the clean mortar, I'm going to now start to grind the tablets. So in the iron tablet, the iron is in the +2 state. Iron will naturally oxidize from +2 to +3, and in order to stop that oxidation happening, once I've got my tablets finally ground down into a powder, I add in my 100 ml of sulfuric acid. Grind that down a little bit more, and this should help dissolve the iron tablet, but also stop the iron from going from +2 to +3. Now the sulfuric acid is added, we can now transfer this washings into the volumetric flask. I'm going to transfer this iron solution into a clean, dry 250 ml volumetric flask. But as you can see, there's a lot of remaining compound in the pestle and mortar, so I'm going to rinse that out with the remainder of the sulfuric acid. To ensure that all the washings are in the volumetric flask. Next, using the ionized water, I'll now fill the volumetric flask until the bottom of the meniscus is in line with the graduation mark on the neck of the volumetric flask. Add the deionized water until the bottom meniscus is in line with the graduation mark at eye level. Stop at that and invert it approximately 20 times to ensure I've got a homogeneous solution of the iron tablet dissolved in 250 ml of water with sulfuric acid added in order to stop the iron from going +2 to +3. Next, I want to take a sample of 25 ml of the iron solution. So transfer from the volumetric flask into the 250 ml beaker. And I'm using a 25 ml pipette. Put the tip of the pipette into the bulb so it's held firmly. Then press the button mark A to expel the air out. Then I'm going to draw water into the pipette to clean it. Like that. And then I'm going to press the button marked E to expel that liquid out. And now I have a clean pipette. There's a little drop remaining at the bottom, so I'm going to press the button marked S and squeeze out the last remaining amount of water. And now I'm going to rinse with the solution it's going to contain to ensure I don't dilute the solution. So again, draw the liquid up into the pipette. Now my pipette has been rinsed out. I can And now I can measure my 25 mils of the iron solution. So don't put the tip of the pipette right to the bottom of the solution, because there are some precipitate particles at the bottom of the beaker. I'm going to draw the liquid now up into the pipette. This is a 25 ml pipette. So draw the liquid up until the bottom of the meniscus of the iron solution is in line with the graduation mark here at eye level. If you go too far, which I'll do on purpose, you can press the button marked E, and then the liquid level goes down until the bottom meniscus is in line with the graduation mark at eye level. Now I'm going to transfer this 25 milliliters of the iron solution into a 100 ml conical flask. This is a clean, dry conical flask. So let's tip the pipette over the conical, press the button marked E, and let the liquid run down into the conical flask. And then you will notice at the tip of the pipette there's a tiny drop remaining. Touch the pipette off the side of the conical flask, and we've now ensured that 25 milliliters of the iron solution has been transferred into the conical flask. Next, I need to fill the burette. So to fill the burette, first of all ensure the tap is closed, so it's in the horizontal position. And then I have my potassium permanganate solution, my 0.015 potassium permanganate solution. And fill the burette and keep filling it until there's about a couple of milliliters above the 0 mark. And remove the funnel. It's important to remove the funnel at this stage because there can be a few drops of solution remaining on top of this funnel, which can drop into your burette as you do the titration, so affecting your end figures. Next, we need to fill below the tap. There's an air void below the tap, so when I open the tap and let the potassium permanganate solution run out, it'll fill the air bubble. And now I can bring the burette until I can let the meniscus down to the graduation mark. With the potassium permanganate solution, because of the intense purple colour, you read from the top of the meniscus in this particular titration. So the top of the meniscus is at the 0 point, and our burette is now ready to do the practical. So, in order for this reaction to take place, the potassium permanganate will be reacting with the iron in the +2 state in the conical flask. In order for that reaction to take place, I need to add in 10 cm cubed of sulfuric acid. So this is the second time sulfuric acid has been used in this particular reaction. Now, taking note of the starting point at 0, I'm going to slowly add in the potassium permanganate solution. As the potassium permanganate reacts with the iron +2, it turns colourless. But when all the iron +2 has been turned into iron +3, the potassium permanganate will no longer have anything to react with and remain the purple colour. So the end point of this reaction is the first persistent purple colour remaining in the conical flask. That purple colour is a very, very, very faint pink colour. So I'm going to shake, add in my potassium permanganate, and you'll see instantly in the conical flask the potassium permanganate decolorizing. If you inadvertently put some potassium permanganate on the side of the conical flask, using your wash bottle, you rinse that solution into the conical flask. This will not affect the end point of the reaction. So keep adding the potassium permanganate, and as you can see it decolorizing. And this is the rough titration, so you don't have to worry about the end point. You're doing your rough titration to see where the end point of the reaction is, and then you can do 3 more titrations after that to ensure you get accurate figures. So you can see it's taking longer for the decolorization to occur because there's less iron +2 remaining in the solution. So you can see now persistent pink colour remaining. And I can now measure again from the top of the meniscus, and I can see that it's gone from 0 to 15.5, so it's taken 15.5 milliliters of my potassium permanganate solution to convert the iron +2 into the iron +3. And you can now work out the calculation of the percentage